Hello. Hello.
Hello, sir.
ସୁଜିତ ଅଛି। ହ୍ୟାଲୋ। Hello.
Yes, sir.
Learners, am I audible to all of you? Hello. Barsarani. Hello.
Yes, sir.
Hello.
Yes, sir.
हाँ सुबिला है ये तो पोर साउंड कहीं हो जी पिलांग पटु हाँ असेट कर दो ना आप हेलो हेलो वर्षाराणी हेलो
Yes, sir. Yes, sir.
इतने पोर साउंड कौन हो जी आउ नहीं बता दो ये थी फुल साउंड Am I clear to all of you? Hello.
Yes, sir.
Hello, Barsarani.
Yes, sir.
Koji. It is Subhuni clear. Okay. Now I am going to start another chapter, that is your continuity, differentiability and higher order derivatives. First of all, we will go to start the chapter continuity. Before going to start the chapter, kindly you write your enrollment number in the chat box. Please write your enrollment number in the chat box. Barsarani, please write your enrollment number in the chat box. Okay. All you are requested to write your enrollment number in the chat box. Now I am going to start the chapter, that is your continuity. Before starting this chapter continuity, already you know about the limit of a function. That is when a function fx is given, if we found the limiting value of that function fx when x tends to a, at that time we will find, or we are going to test for the continuity of the function at the same point x is equal to a. You have given a function fx and you have given to test the continuity of that function fx at a point x is equal to a. How you will verify whether that function fx is continuous at that point or not? First thing, before going to test for continuity, we will derive three things. First of all, we will test the continuity of the function, whether it exists or does not exist. That is, limit x tends to a, fx should exist. Second thing, that limiting value which we find, it must be finite. It may not be infinite. If it is infinite, that one of the condition fails. The third thing is the functional value of that function fx at x is equal to a is also equal to the limiting value. If these three conditions satisfied in the function, then that function fx is said to be continuous at that point x is equal to a. Do you follow me, Champa? Hello, Champa?
Yes, sir.
You have given a function fx and given a point x is equal to a. Our aim is to test the continuity of that function at the given point. That is, we have to find whether the function fx is continuous at the point x is equal to a or not. The very definition of the testing the continuity of a function, that is, a function fx is said to be continuous at x is equal to a if it satisfies the following three conditions. The first condition is limit extends to a fx exists. Second thing, the limiting value must be finite. Third thing, the limiting value of the function is equal to the functional value. What is the functional value? If fx is given, for example, fx is equal to 2x plus 3. For example, fx is equal to 2x plus 3. And that is when x is equal to 2, at that time fx is equal to, that is, if fx is equal to 2x plus 3, when x is equal to 2, that is f2 is equal to 2 into 2 plus 3, that is equal to 4 plus 3, which is equal to 7. That is a function fx is said to be continuous at a point x is equal to a if it satisfies three conditions. First of all, the limiting value of the function exists at that point. Second thing, the limiting value must be a finite value or a finite number. Then third thing is the limiting value is equal to the functional value. But we have already find that is the limiting value. If I put in place of x is equal to a, the fa is called as the functional value. If the functional value is equal to the limiting value, then the three conditions are satisfied, so that the function is said to be continuous at the point x is equal to a. I am discussing one example. You have given a function fx is equal to 2x plus 3. Test the continuity of the function fx at x is equal to 2. First, find limit x tends to 2 fx. When x tends to 2 fx, that is limit x tends to 2, the value of fx is your 2x plus 3. That the limiting value of 2x plus 3 when x tends to 2, that is 2 into 2 plus 3, that is equal to 4 plus 3, 7. So the limiting value of fx exists when x tends to 2, that is equal to 7. This first condition is satisfied. Then the second condition is that limiting value is a finite number or finite value, that is equal to 7 is finite, it is not infinite. The third thing is, since fx is equal to 2x plus 3, so f2 is equal to, that is 2 into 2 plus 3, that is same 7. So the limiting value is equal to the functional value, that is equal to f2. Since all the three conditions are satisfied in case of fx, so that function fx is said to be continuous at the point x is equal to 2. That is the very definition of continuity. Given a function fx, given a point x is equal to a, and we have given to test the continuity of the function, given function at the given point. That is, if from any above three conditions, if anyone fails, the function is said to be discontinuous at that point. Next, I am given another thing here. Let fx is equal to, let this is equal to sine 2x by x when x not equal to 0. Fx is equal to only to when x is equal to 0. Test the continuity of the function at x is equal to 0. The function fx is equal to sine 2x by x. There are two conditions for that function. When x not equal to 0, the value of fx is equal to sine 2x divided by x. And the function fx is equal to 2 when x is equal to 0. We have to given to test the continuity of the function at x is equal to 0. You know that is the limiting value. If limit theta tends to 0, sine theta by theta, that is equal to 1. You know it. So that fx is equal to sine 2x by x. First of all, we will test for the continuity of the function fx at x is equal to 0. First, find the limiting value, that is limit x tends to 0 fx, means limit x tends to 0. When x tends to 0 means x is not equal to 0. Since a function is defined for two cases, that is for x is equal to 0 and x not equal to 0. Since x tends to 0 means it is here x not equal to 0. So for x not equal to 0, fx is equal to sine 2x divided by x. To find the limiting value, multiply numerator and denominator by 2. That is, in the denominator it is 2x, in the numerator that is another 2. So 2 is a constant. Take to the outside or take to the first, that is 2. Limit x tends to 0, sine 2x divided by 2x. That is equal to 2. Then limit x tends to 0, sine 2x by 2x. That is equal to 1. Because we know sine theta by theta, theta tends to is equal to 1. So 2 into 1, that is equal to 2. First, the limiting value of the function fx, that is exists. That limiting value is equal to 2 means it exists. And the second condition is also fulfilled. That limiting value is equal to 2, which is a finite value. Limit x tends to 0 fx, that is equal to 2, which is finite. The third thing, that is limit x tends to 0 fx, that is equal to 2, which is equal to that value equal to f2. That is equal to when x is equal to 0, f0 that is equal to 2. Since limit x tends to 0, fx is equal to 2 and f0 also equal to 2. So that the limiting value is equal to functional value. So all the three properties or conditions for continuity is satisfied in this case. So that the function fx is continuous at the point x is equal to 0. For testing the continuity, we have to verify three conditions. That is, at the given point, the function has the limiting value or the limiting value of the function exists. Second thing is the limiting value what exists, it is a finite value. Third thing is that limiting value is equal to the functional value. Functional value means at x is equal to a, the function has the value fa which is equal to the limiting value. So that the function fx is continuous at x is equal to a. Here the function is given fx is equal to sine 2x by x at x not equal to 0. That fx is equal to 2 at x is equal to 0. And it is given that we have to verify at x is equal to 0. So that the function fx is continuous at the point x is equal to 0. But this function is also, we can, if the function is given in another way, that is equal to fx is equal to sine 2x by x when x not equal to 0. But when x is equal to 0, the function fx is given equal to, that is called 3. At this case, the function will be discontinuous at x is equal to 0, because the functional value and the limiting value, they can never be equal, because the limiting value is 2, which is finite, but that limiting value is not equal to the functional value that is equal to f0. Because when fx is equal to 3, when x is equal to 0, at that time these two values are unequal. They are not equal. So the function will be discontinuous at x is equal to 0. So for the continuity, when we have given to test the continuity of a function, then we have to verify these three things. First of all, we have to verify the limiting value of the function. Second thing, that limiting value which exists, it must be finite. Third thing is that limiting value must be equal to the functional value. If all these three conditions are satisfied, then the function fx is said to be continuous at the given point x is equal to a. Otherwise, the function is said to be discontinuous at that given point x is equal to a. Sometimes when we are going to verify the limiting value, there are some functions we have to find the right hand limit and left hand limit. In case of right hand limit and left hand limit, if the right hand RHL and LHL, if the right hand limit and left hand limit of two functions are different, then also the limiting value does not exist. So to be or the limiting value should exist only when both the RHL and LHL are equal, and those two values if equal, the limiting value exists, and that is the value of the function or the limiting value of the function at the given point. Otherwise, if the limiting value or the right hand limit of a function is not equal to the left hand limit of a function, at that case we can say that the limiting value of the function does not exist. Since the limiting value does not exist, so for the first condition of the continuity is not satisfied. So don't go to the second or third. Automatically it does not satisfy the first condition, so it is discontinuous at that point. Next is your differentiability. That is some, I am giving some theorem that let f is a function which is continuous at x0 and g be a function which is continuous at fx0, then the composite function g of f is also continuous at x0. That is the domain of let it is D, capital D, that is equal to such that x belongs to domain of f such that fx belongs to dom g. And we have given x0 belongs to domain of f and fx0 belongs to domain of g. Then x0 belongs to D, let xn belongs to D such that xn tends to x0. Hence, as f is continuous at x0, so fxn tends to fx0. Since g is continuous at fx0, so g fxn tends to g fx0. That is, g of fxn tends to g of fx0. Hence, g of f is continuous at the given point x0. Naturally, obviously it occurs. Next is your, next we'll describe about the differentiability of a function. That is the function to test the differentiability of a function. That is your, if a function fx hello Borsa Rani, hello Borsa Rani,
Yes, sir.
what I am saying, is it audible to all of you? Hello.
Yes, sir, it is audible.
Yes, sir.
Next is your Priyanka.
Yes,
hello.
sir.
Okay, please listen me. Next, that is we have to discuss about the differentiability. That is, in what case we can know that the function is differentiable, that is its derivative exists, and then what value is its derivative. In what case the derivative exists and what is its value. First of all, definition. Let f is a function from x to r and let a belongs to x. Then f is said to be differentiable at the point a if there exists a constant m belongs to r depending upon a such that given epsilon greater than 0, there exists delta greater than 0 for which x minus a mod less than delta implies fx minus fa minus m into x minus a mod less than epsilon into x minus a mod. That is this thing. That is, if limit x tends to a fx minus fa divided by x minus a is equal to m, at that time we say that f is differentiable at x is equal to a, and we call m to be the derivative of f at x is equal to a, and it is written as f dash a, and that is written as f. A function fx is said to be differentiable at x is equal to a if limit extends to a fx minus fa divided by x minus a is equal to m, or that limit extends to a fx minus fa by x minus a exists, and if that value is equal to m, we say that the function f is differentiable at x is equal to a, and m is its limiting value, and that limiting value is its derivative. That is, m is its limiting value of fx minus fa by x minus a, and it is written as f dash a. That is, f dash a is equal to limit extends to a fx minus fa by x minus a. That is, f is said to be differentiable, and it is the value m which is its derivative. Next is your, we know the differentiation of many different functions, or a differentiability of different functions. That is your sin x, cos x, tan x, cot x, sec x, cosec x, like that ln x and e to the power x, a to the power x, and the differentiability of a constant function. We have already know it. So that anybody, Barsarani, can you say about what is the differentiation of sec x or the derivative of sec x? Barsarani, can you say what is the derivative of sec x? Priyanka? Priyanka? Hello?
Yes, sir.
What is the derivative of sec x? Can you say?
Tan x.
No. Derivative of sec x is
Tan x
that.
sec x.
Okay, okay. Please repeat again.
Tan x sec x.
Okay, sec x into tan x or tan x into sec x. Very good. That is the derivative of sec x. Similarly, the derivative of cosec x. Derivative means that the function is differentiable, and it's differentiate. When we differentiate, we get this value. That is derivative of cosec x minus cosec x into cot x. Derivative of cot x, that is minus cosec square x. Derivative of tan x, that is only sec square x. Simply derivative of ln x, that is 1 by x. Derivative e to the power x, that is e to the power x. Derivative a to the power x, that is your a to the power a is a constant. That is a to the power x into ln a. Like this is the differentiability. Then is your hello? Hello? Priyanka Subhuji? Hello?
हाँ सर शुभुजी.
So next is your differentiation of some other functions. That is your, you also know, like the left hand derivative, left hand limit and right hand limit, there are also left hand derivative and right hand derivative. Left hand derivative and right hand derivative. If a function whose left hand derivative and right hand derivatives both are equal. Both are equal. At that time, its derivative exists, and that is the value of the derivative of that function. If the RHD and LHD, that is right hand derivative and left hand derivative, both are unequal, at that time the derivative of the function does not exist. This does not exist. Please wait for 1 minute. Hello. The left hand derivative and the right hand derivative of if a function both are equal, then the derivative of the function exists, and that value is its derivative. Definition: let f is a function from I to R, where a belongs to I. The function f is said to be have a left derivative at the point x is equal to a if there exists m belongs to R such that limit x tends to a minus fx minus fa by x minus a is equal to m, and m is said to be the left hand derivative or left derivative of f at x is equal to a. If limit x tends to a plus fx minus fa by x minus a is equal to m0 belongs to R, at that time the if m is equal to m0, then the function has the derivative that m or m0, and we say that the function f is differentiable and that m or equal to m0 is its derivative. If m is not equal to m0, then the function is not differentiable or its derivative does not exist. So that if that is you the right hand derivative at the place we find that is limit extends to a plus, and the left hand derivative that we find that limit extends to a minus. That is, if this limit extends to a minus and limit extends to a plus of fx minus fa by x minus a. If both are equal, at that time we say that the function is differentiable and that value is its derivative. Otherwise, the function is not differentiable at that point x is equal to a. Then is your we go for the application of the derivative. Then we go for the application of derivative. And the application of, in case of application of the derivative, this differentiation is used in many places. That is your, first of all, for verifying whether a function is increasing or decreasing, we can use the differentiability or derivative. That is, given a function fx, and we have to verify on the point where the function is increasing or decreasing. First of all, find the derivative of that function, and if that derivative means that is the f dash x, find f dash x and put f dash x greater than 0. If f dash x 0 is greater than 0, for x belongs to some interval I, then in that case the function fx is increasing in that interval for that value of x. If f dash x is less than 0, for open interval, for any interval I dash, x belongs to I dash, at that time we say that the function fx is decreasing in that interval, for all values of x belongs to that I dash. And for getting the tangent and normal, we also use the differentiability. First of all, we have given that a function is given, fx is given. For example, a function fx is given, and that fx means that is the value of y. Find dy by dx. That is equal to, it is the slope of the tangent. That is dy by dx is the slope of the tangent. That is the first derivative of y. We have find the dy by dx means the slope of the tangent, and we have given a point and find the tangent at that point. That is the coordinate of the point is given, and the dy by dx is the slope of the tangent, and it is the slope of the tangent. Tangent is a line and the point is given, and with that point and slope we can determine the equation of the tangent to that line. That is y minus y1. If the point is your x1 y1 and the tangent dy by dx is equal to m, then the equation of that line y minus y1 equal to m into x minus x1. Since if that is fx means it is the equation of a curve, we have to determine the tangent and normal to that curve at a given point. Since the curve is given in the form of a function, that is the fx, or that is y equal to some value. If we find dy by dx, that is the slope of the tangent. Since tangent is perpendicular to the normal, if the slope of the tangent is your m, that is the value of dy by dx, means that is the derivative of y with respect to x. Then minus 1 by m, that is the slope of the normal, because the tangent and normal both are perpendicular to each other. They both are two lines. Two lines are said to be perpendicular when the product of their slopes equal to minus 1. If one of them has slope m, so other must be of slope minus 1 by m. Since dy by dx is only the slope of the tangent, so if it is equal to m, so the slope of the normal is your minus 1 by m. So if the slope is of the normal is given, and one of the point is given in where we will draw the slope. So since normal is a straight line and it has slope and it passes through a point is given, So equation of the normal is your same y minus y1. Slope is your minus 1 by m whole into x minus x1. Simplifying that, we can get learners actually, one of the learner actually has written that, sir, please show us the book. Actually, till date we have not received any book from your course. We are teaching you. Actually, the course structure has given us, and from that course structure we are teaching you. Actually, the book already has not, we have not received yet the books, so that from your IGNO book, if it received, actually what I feel that you have already received those books or study materials from IGNO study center.
No,
You
sir.
both book, you have not received those books, Jyoti.
Sir, not the second year.
Actually, we are teaching with the books, mathematics books, those who are we taught in your degree classes. Those books not of IGNO books, these are other books. That is the also the analysis. Perhaps what I feel, the course of IGNO and our degree courses, perhaps they may not be equal, but they are equivalent. They must be equivalent. Equivalent means they're likely to be equal, they're nearer to be equal, so that we are teaching from those books. Actually, we have not yet received that IGNO book, but I feel if the IGNO book we receive, then we will revise the course for another time. Champa, do you follow me? Hello.
Yes, sir.
Okay. Actually, differentiability, how it is applied in mathematics, or in what chapter we use differentiability or derivative. We use differentiability or derivative for finding the tangent and normal to a curve, or increasing and decreasing of a function. How can you verify the function is increasing or in decreasing? And we also use for, that is for maxima and minima. For maxima and minima, for given a function fx, and it is given that the function has maximum value where, and the function fx has minimum value where. We have to find this. First of all, given a function, for example, fx is equal to some value, that is 2x square plus 3x plus 7, like this. A function is given. First of all, find its derivative, f dash x. Derivative means that is, if fx is written as y, that is dy by dx. If fx directly we write dy by dx is equal to f dash x. F dash x means derivative of fx with respect to x. That dy by dx is also read as derivative of y with respect to x. So that f dash x is given, put it 0, find the value of x. For example, fx is equal to 2x square plus 3x plus 7. Then find f dash x. F dash means derivative of 2x square, that is equal to 4x, derivative of 3x, that is 3, and derivative of 7 is 0, because 7 is a constant. Put that f dash x is equal to 0. 4x plus 3 equal to 0. So 4x is equal to minus 3, and x is equal to minus 3 by 4. Since x is equal to minus 3 by 4, that is a point. At that point, we test for maximum or minimum that function fx. Then find the second derivative, that is f double dash x. That is second derivative means, first it is given a y, find dy by dx, that is the first derivative of y. First derivative of y, or first order derivative it is called. Then find the derivative of dy by dx. It is called as d square y by dx square, or the second derivative of y. D square y by dx square, that is second derivative or second order derivative. It is d square y by dx square, that is second derivative or second order derivative. Or that is a d square y by dx square, d square y by dx square. It is the first derivative or first order derivative of dy by dx, and also it is the second derivative or second order derivative of y. For example, I given that is your y is equal to 3x cube plus 7x square plus 9x plus 7. It is y is equal to 3x cube plus 7x square plus 9x plus 7. First of all, dy by dx, that is equal to derivative of 3x cube, that is 9x square. Then 7 derivative of 7x square, that is 14x. Derivative of 9x, that is 9. Then find a d square y by dx square. Means that is another derivative of dy by dx. That is 18x. Then for derivative of 14x, that is 14. Then dqy by dx is q. That is the derivative of 18x plus 14. That is 18 only. Because the derivative of 18x 18 and derivative of 14 is 0. Like this, when we find the another derivative of dqy by dx is q, it becomes d to the power 4y by dx to the power 4. That is the fourth order derivative, and that becomes 0 because the third derivative is a constant. So the fourth derivative will be equal to 0. So that in this case, that is dy by dx, then d square by dx square, dqy by dx is q, d to the power 4y by dx to the power 4. dy by dx is called as the first derivative or first order derivative. D square y by dx square is called the second derivative or second order derivative. dqy by dx square, that is third derivative or third order derivative. And d to the power 4y by dx to the power 4, that is the fourth order derivative. And this d square by dx square, dqy by dx cube, d to the power 4y by dx to the power 4, those are called as the higher order derivatives. When we are going to verify the maxima or minima of a function, first it is given a function fx and find its first derivative f dash x, put it to 0, find the value of x, then find its second derivative f double dash x or d square by dx square, and in place of that f double dash x, put at the value of x at the place of x, or put that x value from f dash x is equal to 0 in place of f double dash x. If the value of f double dash x is negative or less than 0, the function has a maximum value at that value of x. If f double dash x is greater than 0, then the function fx has a minimum value at the value of x. If f double dash x is equal to 0, then we can't get any conclusion. So if the second derivative of fx is negative or less than 0, then the function fx has a maximum value at x, at the value of x. If f double dash x is greater than 0, then the function fx has a minimum value at the value of x. Do you follow? Hello, Priyanka?
Yes, sir.
You have given a function fx, but you have given a question that verify whether the function is maximum or minimum at which point. First, find the first derivative, that is f dash x, put it to 0, find the value of x, and then from f dash x find f double dash x. If in place of f double dash x, put the value of x, what we have got from making f dash x is equal to 0. If the value of f double dash x is negative or less than 0, then the function fx has a maximum value at x is equal to, or x is equal to that value. If when we are making f dash x is equal to 0, and if we get the value x is equal to a, in place of f double dash x, if we put x is equal to a, if f double dash x becomes positive or greater than 0, then the function fx has a minimum value at x is equal to. And what is that mean? This is for testing for the whether it has maximum or minimum value. But what is that maximum or minimum value? How can we find? Only when we put the value of x at fx, and that value is whether the maximum or minimum. When we find that f double dash x is negative for x is equal to a, So fx has a maximum value at x is equal to a. Put that value of a in a place of x in fx, and that is the maximum value. If f double dash x is greater than 0 for x is equal to a, then fx has a minimum value at x is equal to a. Put that x is equal to a in place of x at fx, and that is its minimum value. Do you follow me? Hello?
Yes, sir.
Okay. Then is your, well, how can you apply this differentiability or derivative to mathematics? Actually, those differentiability or derivative can be used for finding the tangent and normal, for finding the increasing or test for increasing and decreasing of a function, or for finding the maximum or minimum value of a function. For example, there are so many applications of derivative in mathematics. Actually, when we are also testing for the, for example, there is a curve that is circle, and we have to find the maximum area of triangle inscribed in that circle. Only this can be possible by applying this differentiability in that case. So that for a, there are two types of testing of maxima minima. One is your first derivative test method, another is your second derivative test method. The first derivative test method is, I have not discussed with you, but what I discussed with you, that is the second derivative method. But the first derivative method is your long one. The first derivative test method is your long one. That is, if given a function fx and we have to find the point where the function is maximum or minimum, put f dash x, find f dash x and put it to 0, find the value of x. For example, x is equal to 1. That is, f dash x is equal to 0 for x is equal to 1. Then you find the value of at 1 minus h and 1 plus h. If the first derivative changes sign from positive to negative when it crosses 1, then it has a maximum value at that point. If the first derivative changes sign from negative to positive when it crosses 1, or when it crosses that point, when it crosses means that it goes from left to right, then if it is two things, if it changes sign from positive to negative, then the function has a maximum at that point. If it changes sign from negative to positive, then it has a minimum value at that point. If it does not change sign, if the left value is positive, right is positive, or left negative, right negative, then it has no maximum or minimum value at that point. So the first derivative test, sometimes the students feel that it is a long method, but the second derivative method is very short method. First, find f dash x, put it to 0, find the value of x that is equal to, for example, a, and find the second derivative of double dash x, put the value x is equal to a in the second derivative. If it is negative, then the function has maximum value at that point. If it is positive, then the function has the minimum value at that point. And what is that? It is the for the testing procedure, that is whether it has a maximum or minimum. How can you get exactly what is the maximum, what is the minimum? Put that x is equal to in place of fx. If it is maximum, then that fa is the maximum value. If it is a minimum value, then that fa is a minimum value. Thank you all my students. Thank you all. And this is your time actually to end the class. Thank you.
Thank you,
Actually,
sir.
Thank you, sir.
I am now, I requested the coordinator to give us the exactly book what they have brought from the IGNOU Study Center. If they will give us the exactly book, then we can follow that book and we will teach from that book only. Actually, till now we have not received that book, so that we are teaching you only from the book of degree courses. Thank you all. Thank you.
Thank you, sir.